All right, our last lesson for today, 7.3, our last video for today, is on polynomials. So the last two lessons were on monomials. A polynomial is a monomial or a sum or difference of monomials. Now, when we talk about polynomials, there's different kinds. We have a binomial. If you think of that, that means two. So a binomial is going to be a sum or difference of two monomials. A trinomial, tri meaning three, is a sum or difference of three monomials. So if I were to write an example of a polynomial down here, we could have the one that I use as an example in your notes, 2x squared y plus 4 times bd minus 10 times b squared x cubed. So when we're talking about these, one thing that we have is the degree of a monomial. The degree of a monomial is the sum of the exponents of all its variables. So if we think about this, in this polynomial, since it has three terms, this would be a trinomial made up of three monomials. So our three monomials, we're going to find the degree of each one. It's the sum of the exponents of its variables. So here we have x squared and y. Y would be to the first power. So we would add up the exponents. 2 plus 1. This monomial would have a power or a degree of 3. Here we have b and d, each to the first power. 1 plus 1 would give us a degree of 2. Here, b squared and x cubed would give us a degree of 5. So that's how we find the degree of a monomial. Then to find the degree of a polynomial, it's the greatest degree of any term in the polynomial. Remember, a term of the polynomial, each monomial is a term. So in this case, the degree of the polynomial would be the greatest degree of any term. We have degrees of 3, 2, and 5 here. So this polynomial would be to the 5th degree. So again, that's how we find degrees of a monomial and degrees of a polynomial. So just like we started with when we first talked about monomials 2 lessons ago, we're going to talk about identifying polynomials. So we have to state whether each expression is a polynomial. So first we're going to say yes or no. Then if it is, if we say yes, we have to say whether it's a monomial, a binomial, or a trinomial. So in this case, we have just the variable x. We would say, yes, this is a polynomial. Since it only has one term, it would be a monomial. B, in this case, negative 3y squared minus 2y plus 4y minus 1. We would say, yes, this is a polynomial because it's made up of monomials, adding and subtracting. Now in this case, this isn't a monomial, a binomial, or a trinomial because it has 4 terms. But if we look at it, 2 of our terms are like terms and can be combined. So we can say, we can simplify this to negative 3y squared, and we have negative 2y plus 4y would give us a positive 2y minus 1. Now it has 3 terms, so we would say that it's a trinomial. Here, 10x to the negative 4th minus 8x cubed. We would say, no, this is not a polynomial because a polynomial cannot have negative exponents. Because if you think about it, a negative exponent really moves the variable down to the denominator, and a polynomial cannot be divided by a variable. So we would say no because of the negative exponent. Then we had one more on here. Let's It's not wanting to go away for me. The last one we had was 5RS plus 7TUV. We would say, yes, that is a polynomial. And since it has two terms, it would be a binomial. So moving on with this now. Writing a polynomial. We're supposed to write a polynomial to represent the area of the shaded region of each figure. So first we have to know, how do we find the areas of these figures? We know we've got a rectangle and a circle. To find the area of a rectangle, length times width, or base times height. To find the area of a circle, we have pi times the radius squared. So in this case, we have the radius of the circle. Since the circle's diameter is the same as the width of the rectangle, we can say, since the radius is half of that, that the entire diameter or the entire length or width of the rectangle would be 2 times r. So in this case, the area of our rectangle would be 2r times b, which we would rewrite as 2br. You always want to have your exponents in alphabetical order. Then for our circle, we have a radius of r, so our circle's area would just be pi times r squared. So now in order to find the area of the shaded region, it would be the area of the rectangle, 2br, minus the area of the circle, which is pi r squared. And that would be our polynomial in order to find the area of the shaded region there. So then another one of these problems. Here we've got two rectangles. So our first rectangle, our larger rectangle, we would have 2x times 4x. Now we know from multiplying monomials, we're going to multiply the coefficients. 2 times 4 gives us 8. X times x gives us x squared. Then we're going to subtract the smaller rectangle that is not shaded, which is 2x times x, which would be 2x squared. Now in this case, this can be simplified because they are like terms. We have the same variable raised to the same power. So 8 minus 2 would give us 6. The x squared stays the same. So we would say to find the area of the shaded region, it would be 6 times x squared. So now, degree of a polynomial. Find the degree of each polynomial. So we went over this on that first slide. In order to find the degree of the polynomial, we have to find the degree of each term first. So here, we would have, since we have to find the degree of each term, we add the exponents of the variables. So we have m cubed and n squared. 3 plus 2 gives us 5. M to the first and n squared, 1 plus 2 gives us 3. Here we don't have a variable raised to a power, so that has a degree of 0. So then we found the degree of each term. The degree of the polynomial, remember, is the highest degree of each term. So the degree of this polynomial would be 5. Looking at the second one here, x and z would each have a power of 1. So if we look at this, 5 plus 1 plus 1 gives us a power of 7 there. That's the only term. So this polynomial automatically has a degree of 7. And then here we've got a degree of 2, 3, 4, and 0. highest one is 4. So the degree of that polynomial would be 4. Then the last thing we're going to talk about here is writing polynomials in order. The terms of a polynomial are usually arranged so that the powers of one variable are in ascending, increasing, or descending, decreasing order. So here they're going to tell us a specific variable and to write it in either ascending or descending order. So if we look at this, arrange the terms of each polynomial so that the powers of x are in ascending order. So here we are only going to look at the powers of x. So this first one, we've got x cubed. Here we've got x to the first, x squared, and x to the sixth. They want it in ascending order, so that means least to greatest. The smallest degree of x is to the first power, so this term would come first. Negative, you always want to keep the sign that's in front of it. Negative 4x, y to the fourth. Next would come x squared, so plus 3x squared, y cubed. Next would come x cubed, plus 7x cubed. Then the largest one is x to the sixth. Again, we keep that power in front. So minus 11x to the sixth times y. Now here, there's nothing else we can do. We can't simplify this, so that would be our answer. I'm going to go ahead and go down to one that's in descending order. So arrange the terms of each polynomial so that the powers of x are in descending order. So for this one, what we want to do, I'm going to go ahead and look at example B for this one. We have an x to the first here. So our x has a power of 1 there. Our x has a power of 1 there. We have a power of 4 there, 2 there, and 0 there. So again, descending, we want to start with the largest power of x, which would be this term right here. Again, we keep that sign in front. So negative 5x to the fourth, y to the eighth. Then we've got a power of 2, so minus x squared, y squared. This is where it gets a little bit tricky. We have 2 of them that both have a degree of 1. We can't combine them because this one doesn't have a y with it. They have to have the same variable in order to be able to combine our terms. So in this case, you will always write, if you have 2 that have the same degree, if one of them is by itself, that one is always considered smaller. So the one that has the 2 and the y with it would be larger. Then would come the x. Then would come the 3, the constant that does not have a power of x with it. So this would be the polynomial written in descending order. Now on this assignment, they'll tell you which way to write it. As you move ahead in math classes, whenever you're working with polynomials, the general rule of thumb is to always write them in descending order, doing what we just did right there. So again, those are the 3 lessons from the original time we were supposed to be missing. If you have any questions at all, please reach out. I'll be sending out more information this week of what the next month is going to look like for April of this time that we're going to miss. But for these assignments, I'll have you guys, some of you have already reached out and asked me, but I'll have you guys just take pictures of the assignments, send it all as one email to me so I don't have a ton of emails coming in. And once I get that email, I'll get those grades put in. But more information will be coming out as far as what everything's going to look like for the future lessons, grading, all of those different things. Hope you guys are enjoying your time at home so far and that you're able to stay busy.